मेरे पास दोनों एलजी है और मैं दोनों लगा देता हूँ।
this is what I'm going to present is not, it's our version of microservices or what we have learned. It is, please don't treat this as gospel. This is what we have learned, and this just to share our experience. So what I'm going to cover is first a little bit of background on application infrastructure evolution. So how has application infrastructure evolved over the years? I'm old enough to have seen all the phases that I talk over here. And then I'll hone in on the web era and look at how web application architectures has evolved. And then we'll focus on the microservice model. We'll see how it is used, and we'll take a sample case study and go through how we implemented it. So application infrastructure. So what I'm going to do is I'm going to look at infrastructure and its corresponding application architecture, how different models of infrastructure evolved, and how the application architecture evolved along with that. The first is, of course, very early computers were all mainframes, and the applications that we designed in those days were really large monolithic applications, which you had to use punch cards and really dumb terminals in our college, and we had to book time on the mainframe, and we used to get like 1 hour in a day to be able to actually access the mainframe. And from there, so the applications we wrote, of course, they were all terminal-based UI at best. Most of it was output in the form of printouts. So as such, there was no real user interface or like what we know today. That moved into, I think, towards the end of my college days, we started getting PCs in our computer center, and my final project was written on a smaller PC, and the applications then, we started calling them client-server applications. Now, you'll see the distinction between monolithic application and client-server. What actually happened was there was a distinction of what can run on a high-end server server infrastructure, and a client was supposed to be a sort of thinner, smaller application, but both were applications. There was a client application, there was a server application, and we used to write client applications in different application frameworks like C, C++ sometimes. Windows had just come in at that time, so we used VB, for example. VB applications were probably the biggest wave of technology in the client-server era, and on the server end, you had all kinds of server applications and databases on the server. This actually fueled a huge, wave of applications. When in the mainframe era, software was restricted to very large organizations. No common man had access to it. In the PC era, computers came down to people who could afford those really expensive personal computers, and smaller organizations started getting computerization and automation and stuff like that. And so in this era, there was a whole explosion of the real IT explosion happened in this era. But that was nothing compared to the web. So when the internet came in the 80s or so, late 80s I would say, early 90s, that's when the real explosion actually happened. Applications now had to present a user interface on devices which were physically very, very far away from where the application was designed. And so with the internet in the middle, we came up with this N-tier architecture where the user interface was running on a browser which was very remote, and there was a server which was in a data center, and the database was kept in a separate server, the application was kept in a separate server, and the UI was typically on a browser. Browsers in those days were still really dumb, and so most of the UI was generated on the server side, and you just sent out HTML and pure HTML actually. There was no CSS in those days. Down the pipe into a browser, and the browser would just sort of display forms typically. Towards the end of this era, we started, I think the big revolution in terms of richer user interface and richer applications was when Java came on the scene. And Javasoft first released Java, and suddenly everybody started writing applets in the browser, right? And in the browser you could actually write richer UI. We started mimicking how older client-server applications work. So you could say, oh, now you can do client-server applications with a browser and an applet in the browser. So the browser and the applet worked like a client, and server was more like the conventional client-server server. But that evolved very soon, and all this evolution you see is related to infrastructure evolution. So as computers became cheaper, servers became more powerful, the net became more viable, bandwidths improved. That's when the browsers became more powerful, more standardized. I don't know how many of you had to deal with IE 5 ever, or before that. Even IE 6 is bad enough. But in those days we had to really deal with huge mess of browsers. And but over the time, browsers started becoming more standard, richer in capability. JavaScript became more powerful, and gradually we started moving more and more intelligence out from the server into the browser. And I guess there are not too many oldies like me here, so all of you must have started with Ajax, right? Ajax was probably the early development for you, but Ajax came on the scene when browsers became rich enough that you can actually write UI in the browser itself. In the last, say, 10 odd years since the evolution of the cloud, there's a big distinct jump from conventional web to the cloud. Now, what happened was, till the early days of the web, people who drove the software industry were primarily large software companies. It was the IBMs, the technology, in fact, the ones who used to drive infrastructure were in control. And IBM was mainly providing mainframes, then moved slowly into software services, right? And then you gradually had other players like Oracle and ERP vendors like SAP coming into the picture and driving all the technology innovation. But the minute the web and the internet came into the scene, the power shifted from the conventional proprietary technology holders into a completely new set of organizations. Early days it was Yahoo and Alta Vista who wrote search engines, and then that gave way to a whole .com bust. Lots of .coms came on the scene, nothing worked. Very few of them worked. But the technology kept innovating all the time. And then in the last wave, we now have companies like Google and Facebook and LinkedIn and Netflix, who are now way bigger than any of the conventional technology companies. And for a change, the evolution was not driven by people who owned infrastructure, but people who wrote applications. And so the power shifted away from infrastructure providers into the hands of people who actually could write software. Of course, there was a movement away from proprietary technology to open source as well. And so the whole technology space became so democratized that anybody today can write applications which are as powerful or as featureful as anybody else in the world, with a very, very low cost of effort. It's in this space, in this kind of a scenario, that the service-oriented architecture came into the picture. And one of the reasons why the whole service-oriented architecture became feasible in the first place was because bandwidth of network improved and you could have faster communication between various services. So this is basically a sort of evolution of how I have seen in the last maybe 30 to 40 years. By and large 4 decades. And we have gone, I have seen when I passed out from college, I have been working on mainframes. In the last 40 years, it's been a drastic change from that to what we are doing now. So I'm not going to bore you with the first 2 ones, they are completely out of the picture. So we'll focus primarily on the evolution of web, and we'll only focus primarily on how applications and architecture of applications evolved. So let's look at web application architecture models, how they evolved. Initially, like I said, the first set of applications we wrote were all server driven, right? They were large applications. They started very small. I remember the first real web application I wrote was an online banking application, so-called online banking application. But it wasn't doing any banking. It was just presenting statements. So we're just pulling out data from their mainframe system, and they had these so-called supercomputers, which was running their banking backend. We used to pull out data from there in files. These files were FTP'd onto a web server which was hosted in a data center, and then we basically just presented those statements to customers. And that was supposed to be a big deal. But then the application started becoming richer and richer, and you could do more and more things with those applications. Now, when we started those applications, infrastructure that was available was typically Windows was rarely used, but I think Windows came in soon after that and came up with this whole application server pages, or ASP, which was their first version where you could actually embed something like VB code inside HTML itself. So there was some enterprises started using the Microsoft stack, but the large part of the web was driven by Unix and Linux and Solaris and all the different versions of Unix. And the tools that we used were primarily Perl. PHP came in a little later. Initially Perl, a lot of C, and we had what we used to call a CGI. So CGI is, I haven't forgot the full form of CGI. But basically you had a web server which could invoke an application which would pass HTML back to the web server and sort of pass it back. Now what happened was, the rate at which these applications, the demands of these applications grew was so high. We deployed online banking. The next thing you know, they said, now that you're doing statements, why can't you also have a facility to enter forms? Right? You can do checkbook applications and this and that and that. And how fast can you release it? And so, okay, we used to write Perl code and write new stuff, and we were young and bold and careless, and so we just kept writing code, right? And these applications started bloating up and bloating up and bloating up and bloating up. And it came to a point where they were just not sustainable anymore. It was the only person who could write or make even the smallest change in a simple form was that one person who started writing the application. And of course, if something broke, it was like disaster. But we got away with it because most of the customers did not expect much in this era. They dealt with failures, which was way better than earlier. You don't have to physically go to the bank anymore, right? You can at least check your stuff online. Connectivity itself was not so great, so nobody really complained when the application went down. But that changed because infrastructure was kept improving, and customer demand started becoming more and more, they started becoming more demanding. So if you see in the monolithic era, there are some key elements. So first thing is, because we wrote code in one big application, all the so-called components at best were tightly coupled, right? They were just like in-memory libraries which you could just call. The code started becoming really large, very difficult to change. If you had to do release cycles, either you were running off the seat of your pants and just releasing with, hoping for good luck, or you had a strict governance process where you said you can't do a release till everything is tested. You do an extensive manual testing of all the features, and only then you release the next version. So either you compromised quality for speed, or if you wanted quality, you compromised speed, and then you had really long release cycles. All the development was done using waterfall, so you had to clearly define what you wanted. You sign off on the specifications, customers used to sign off, and then after that you made absolutely no change. And any new change required a new release, which went in typically after at least 6 months release. So no new feature was released before 6 months. If there was an error, it was highly sensitive to errors. If error happened somewhere, the whole application would come down, database would come down, and then you had to scramble at night sometimes to the data center and figure out what happened. The data that we used here is a normalized data model. Normalized in the sense relational databases, right? So we had really large relational databases, and all the data was sort of put into very strictly normalized. Nothing could be duplicated. Space was really expensive at that time. So we are driven by saying no duplication. You were married to the technology stack, right? If I started with Perl and I swore with, I still have some code in Perl, unfortunately. It's very difficult to manage. We still have some customers who are using our Perl applications, trying to drive them away, but they don't go away. So we were really married to the technology stack because we swore by it. There was no intercompatibility between technologies, and the only way you could grow was to take the same set of technologies and grow, right? So there were very strong camps. There was the Microsoft camp. There was the Unix and Perl, and the PHP came on the scene. PHP camp, and everybody was like in their own world, technology silos with some development in some areas in each of these. So there was no democratization at all. Development teams were really large because they had to interact very closely with each other. They had to work closely with each other, know what the other person has done. It wasn't always possible to have clear documentation, so you had to have very, very tight integration between even the teams. And of course, infrastructure was really expensive to scale. So if you look at this diagram, it's sort of a representative diagram where you had a web browser, an application with all the different modules within it, and there was a database, a normalized database, and there were lots of tables with joins between them. So in this era, basically, if you look at the main attributes, components are libraries of reusable code. Communication between components in process calls, so you just basically just made procedure or method calls. If there was any orchestration between the modules, it was just application logic. All the technology stack was a single platform. And database centralized, a single database, a unified data model, and everybody swore by transaction consistency. So you could not have a scenario where there was any mismatch between somebody writing and somebody else reading something else. So transaction consistency was very important. That led to the second in the once this whole thing started becoming too big to handle, then we said, hang on, it's becoming just too much of a mess, right? There's just no way we are going to be able to afford to have 6 months release cycles. We need to speed up our development. And the only way we can do that is break up the whole application into individual components which are developed by separate people. So it was driven not by architectural model, but just a matter of saying how do you manage an application. The only way to manage is to split up this whole large team into individual teams and say, you only develop this, right? Well, that was done before too, but then you had to compile all of it together into one executive. And that's when things started failing. So it's a no, just break it out into, and then this master stroke of service-oriented architecture where you say, split up the application to services, let each service be deployed separately. That was like innovation, great innovation. But it wasn't possible to split the database, right? It's a database where all the services used to share and synchronize with each other. So you still had services which were, though they were independently deployed, they talked to each other very strictly. There was a strict governance. It was like a contract. Each service had to have a strict contract saying, this is my input and output for each service endpoint. So the code base was partitioned, but the database was still unified. It was slightly easier to change, easier to manage. We were able to speed up the release cycle slightly. So instead of 6 months, it came down to 3 months, sometimes 1 month even, if you're really efficient. And we started talking about agile development and iterative development. So errors were easier to handle, of course, because you had different code bases, and if something failed in one service, you still had to bring the whole application down, right? But at least you can only fix one particular service which failed. Like I said, the data was still normalized, it was still unified. We didn't figure out how to split the data into individual components yet. And primarily because the data model was still highly normalized. So you had strict joins, database performance was driven by RDBMSs, and so the only way you could do that is to keep it all in one large database. So this is the sort of model. You had different application components, but the database was still the same. So here you see that the components are independently deployed services. Inter-component communication is through actual request-response interface between these components. So you had RESTful APIs, but each component could call the other using a WSDL definition of what the contract is. And then you could just consume the services from one to the other. Interface definitions, slowly those strict contracts became discoverable contracts. So you had WSDL contracts where you could actually ask what are the services available in your environment and then consume. Slowly the technology stack became a little more disparate. So you could have services which could be written, one service was written in Perl, where there's a lot of regular expression required, you use Perl, or PHP. Where there was high performance required, you could write it in C, but the database was still the same. So in the persistence layer, it was still centralized persistence, still a single database, still a unified model, and still transaction consistency. That led to, so the big problem with the service-oriented architecture or the whole services was that scaling was a problem. So functionally it didn't give trouble, but when you started getting large amount of data, it just didn't sustain. That model failed because the database was still not split. So you still, your application could be, you had load balancing for each service, right? So if a particular service was consuming more bandwidth and had more traffic, you could just load balance that individual service without having to duplicate the whole application infrastructure. So as such, scaling at the application level was okay, but database was not scalable. So the big problem was the bottleneck shifted from application to database. So as the amount of data started increasing and we started handling larger and larger volume of data, that's when the so-called service-oriented architecture failed. And actually, if you see here, the complexity in the service-oriented architecture was the whole idea was saying, because you had independent people developing independent services, how do you coordinate between them, right? Either all of them knew all the other contracts, which was really difficult, right? Because one team went and made changes in their API. Other teams said, hey, your API is not working. So you had a lot of cross communication and conflicts between these teams. And so in the latter part of the SOA, the service bus model came into the picture. Enterprise service bus, you had MuleSoft and all these guys, TIBCO, come up with service bus concept. And service bus concept was saying each service doesn't bother about anybody else. Okay? If there is any interface between the services, we'll build those interfaces in the service bus. And so we shifted the problem, okay, from each of those teams into one centralized team. And so you had these so-called, I don't know what they used to call themselves. They were sort of business analysts and people who used to draw the workflow diagrams and say, this will call that service, this will call that service, and all the business logic was coded in a graphical format in a workflow, and you could do that in the service bus. And as long as the workflows were simple, it worked fine. It sort of alleviated some of the problems of fighting between the different teams. But as the workflows became more and more complex, the whole bottleneck shifted from applications into the service bus itself. So if you had to make any change in the workflow, these guys would act so pricey. They would say, not possible. Because the mess that you had in your enterprise service bus was so complex, all the permutations and combinations of use cases had to be coded inside the enterprise service bus. So you just sort of removed the complexity of interface between components and services because there was too much of fighting and just no way to figure it out. You just shifted to enterprise service bus and became a single point of failure. So the service bus became the point of failure from an application perspective, and the database became the point of failure from a data perspective. So what the solution was really very obvious. You say each service should manage their own data. Sounds very simple, right? So you say all of the services you just, I don't want a central point of failure. Let each service manage its own data. A big problem here is that the minute you split the database, you can't use normalized data models anymore. This is very, very big. Even till today, I find the biggest problem of adopting microservices is the splitting of data. Right? It's not splitting application. We always wrote object-oriented code. We can easily split. If you see the same components, right? If you see them monolithic, you had user manager, products manager, inventory, orders. You shifted that into SOA, just split those classes into individual executables or jar files, right? No big deal. Anyway, database was the same. Where the problem comes is when you want to split the data. So, first question is how do you split and what do you split? What is a service in the microservice model? So first let's look at what is a microservice. So first thing is it's small. Small means, first of course, it's a service, so it provides RESTful APIs. All the APIs relate to one particular functional domain or an entity, right? So this is a classic one. You have one service which manages users, one which manages products, one which manages inventory. The classic e-commerce application kind of a scenario where you have users coming in, browsing products, they place orders if they are available in inventory. So what we did was we said, okay, now each of them have to, and this we did in the SOA model itself, right? So we just split the whole thing functionally. And each service should be possible to handle with one Scrum team, not larger. So in the initial days of SOA, there were still larger teams, but then you further split and split and split and split till you said each one, and of course Agile became more and more prevalent. That's when we said each service is one Scrum team. If the functionality became bigger than one Scrum team, then you split it. That's golden rule. Because our whole reason for going to microservices is to manage applications which were complex and which were too big. And so if more than one Scrum team was required for a service, you looked at splitting it, even if it meant that there is some amount of interface between the two. The second aspect is that it's independent. Now remember, in the SOA we did application independence, but we did not do data independence. So functional independence was done in SOA itself. Data independence is when each of these services owns its own data. Of course, technology independence was there in SOA, but denormalization came into the picture in microservices. So let me spend a little bit of time on this denormalization because that's the trick of splitting your data, right? So let's take users, products, inventory, and orders. Now in a conventional sense, in the RDBMS structure, what you would do is you say, okay, users are master data. Okay? User registers, you put that user in a user database. Product is a master database. You can manage products, they're by and large independent of each other, independent of users, master data, put it in a product database. Inventory is related to products, right? So you created a primary key relationship between product table and inventory table, and you would create inventory, manage inventory for various products. Orders is which user places an order for which products, and so you basically created a join between users, products, and orders. So that's how you do a normalized data model, right? Now let's look at a scenario. A user comes in, places an order, finds that the product is available in the inventory, okay, and gets the order is completed. Now, this was for a product. Let's take some. Let's say, give me some product. No, I'm talking about what product did he order? Mobile phone. So he orders a mobile phone, right? And it's available in stock and he buys it and the order is completed. Now what happened was, the provider of this product had made an error in the description of the product. Okay? The customer got the mobile phone and he said, hello, you said it was 32 GB, this is just 16 GB. Okay, and he complains and says, oops, mistake in the description. Okay. Now, what has happened is he has probably, there are various kinds of issues that will come into this kind of scenario, right? Either he actually paid for a 16 GB and he got a 32 GB, or he paid for a 32 GB, got a 16 GB. So all kinds of issues can happen and you have to correct the data. Now, when you correct the data, what has happened is all previous orders, because it's a joint table, all previous orders will get affected, right? So if you have a clean architecture saying no duplication of data, I don't want to keep order data anywhere, and it has to be a clean normalized structure, then you have to be able to make sure that you then introduce versioning of products, right? You say, no, that order was relating to the previous version of the product. Now if I make a change in the product, I have to create a new version of the product, and I have to remember relationship between the new product and old product. You basically end up with a huge mess in a relational normalized data model. Now let's look at if you had what's the difference between this scenario and the denormalized structure. In the denormalized structure, the order database has to remember not only the unique product code of the product, but the description as well, right? And all attributes of the products. So what the order database, so denormalization means you duplicate the data of the product from the product database into the order database. So every line item in the order not only has details about the order in terms of quantity and which user placed the order, etc., but even all the product details. So because the order needs to know about the user, needs to know about the product, and about additional attributes of the product, about the order, all the data of users and all the data of products is duplicated inside the order database. Okay. Now you look at a scenario. If the order database now remembers which user placed the order for which product at what time, because it has duplicated that data in the order database. If there is any change in the product or any change in the user, it is not necessarily going to affect the old orders, right? So old orders are going to remain the way they were when the order was placed. If you make any change, it's like a new order, or if it's a subsequent change in the order. And so it's easier to manage because the order database now becomes a single source of truth for what happened at that time. So denormalization means basically you duplicate data, right? That's as simple as that. Now once you duplicate this data, because you have two different databases, you can actually split orders database into a completely independent database, and you can put users and products into independent databases. That's the main trick behind separating data, right? That you actually have to duplicate data. Now the big problem is, how do you keep them in sync, right? If you duplicate data, why we did not duplicate data? Because it is difficult to synchronize them. So that's when you come up with events. So what events does is, see, how does the orders database know that it needs to make a change in a product? When somebody makes a change in the product database using the product manager service, the product manager service will publish an event saying this product has changed. Okay. Anybody who's interested, please listen to it and figure out what you need to do. We said this product, mobile phone XYZ, has now got, instead of 16 GB, it's 32 GB. Okay. So the orders service can listen to that event and say, okay, looks like, let me see if I have any order for that particular product. If I have an order for a product, if it is not already completed, right, let me go and change the description. If it is completed, I will not change the description. Now, this is a call that the orders service can take, right? And there is no tight integration between the product service and the order service. The product service has no knowledge that there even exists an order service. And the order service can independently take a decision about how to manage its own order database. And that event could have come from anyone. It could have come from a product database, it could have come from a third party, sales channel, maybe, right? It doesn't make any difference. So you can expand your whole application from saying, instead of only having my web portal, let me create a native mobile application, okay? And let me keep my products cached in the mobile application. You can do that. It's not going to break anything because all the services are maintaining its copy and everything is driven by event. So basically, event-aware service means that if there is any significant event in your service, you'll publish it to the event queue. And you'll subscribe to all events which are dependent and which affect your domain or entity. What this, of course, means is that everybody needs to understand what events are being generated, right? So there has to be some way in which you are able to share with everyone what are the kind of events. So it's not like there is no integration or no knowledge. You still need to know that there is an event of a product getting modified, which can be subscribed to by the order service. Any questions so far? Okay. So the event store or event queue is a very important part of why microservices work in the first place, because without an event mechanism, if there was no publish subscribe event queue, the services would still have to talk to each other and figure out what has changed and the interdependence. With the event queue, you are now actually able to make the services independent of each other. And that's a very crucial and sometimes underplayed capability. So that's one of the most important things. The next implication is that services keeps changing, right? In the classical model, what we do is, when a service has to be modified, we would, in the SOA generation. We could make a change in the service, and then we had a downtime, say, put the service down, okay, at night, release the new service, and link it back to the ESB, and then you can work fine. Okay. Or in the ESB, you can have the new service, but you have to rewire the ESB. So you anyway have to bring this application down, because when you're rewiring the ESB, the application has to go down. In the microservices model, the old and the new can coexist. So basically what happens is, imagine, actually I should take order manager. Suppose order manager new version comes up, right? And you have to make significant change in the order manager service. The old and the new order manager versions can coexist, okay? And nobody else needs to know, right? Because it is anyway listening to events. So if a product got changed, it got published, both the old and the new order service is listening to the same set of events. And both of them listen to it and respond equally with no knowledge of each other. Right? So that is what helps to make sure that when you make a change, you can have new services coexist with the old one, because without the event mechanism, you would still need to tell the other services, hang on, now there is a new version of the order service, and instead of hitting this particular IP, now you have to hit that IP of the order service. But in an event model, you still don't have any of that headache. You can just say, subscribe to that, and you're done. So one of the biggest benefits here is what is called as green, blue, or A/B testing. So typically what happens is you have a live application, and it's deployed, okay, and now you made a new version. Of course, you did automated testing, and all of that stuff is great. But sometimes, till the users actually use it, you don't know whether it actually works, right? So what you can do is, you release the new service, you make a change in the UI, and you deploy only a subset of users. Okay, and you measure now usability, the latency, all the web analytics give you information about how are users using your application. And you can track those users who are using the new service and the other users who are using the old service. And you can actually compare all these metrics to see which service actually works better. And sometimes you just roll it back. No, doesn't seem to be making a difference. Let's roll out this service and rewire all the users to the old service. The new service works great. Let's rewire all the users to the new service. This dynamic capability of modifying the software while it is alive and while it is running, you see none of the large web applications ever come down, right? There's no downtime to Facebook, there's no downtime to LinkedIn or Netflix or Google. The only way you can manage that kind of uptime, it was like close to 100% uptime, is to make sure that you have a mechanism to modify any part of the application, okay, and test it in live production scenario. And this is the only way you can do it, otherwise you can't do that. So therefore, not only is it extensible, it's expendable. Expendable means if the service is bad, you just put in a dustbin, right? We wrote the old version in PHP because we had PHP developers. Okay, now PHP is giving too much of security risk. Let the old service work. New service will work in a completely different tech stack. Re-engineer the whole service, and once the new service is proven to work seamlessly, you just take the old one and put it in the dustbin. So it's expendable. So if a service is re-engineered, if it goes down, has to be brought up again. Another scenario I think I did not tell you about is this last point here, ability to regenerate its data. Now look at a scenario. Let's say your order service went down. Okay? It went down and all the data of orders was lost. What are you going to do? Because now all the data is split amongst multiple databases. So either now you have to take a backup of all your databases and maintain archives of your data, okay, or you are basically screwed. So that's what brings us to this, the model of what is called the event sourcing. So what we say in event sourcing is that the single source of truth is not these databases of belonging to each of the microservices. The single source of truth is the events themselves. So let's take a scenario, that same scenario, right? User went, placed an order for a mobile phone, and got the order. Suppose in the middle of the order service went down, and the whole orders database got corrupted. What's going to happen? What's going to happen is when the new order service comes up alive, hopefully with a bug fixed, okay, it comes up alive and says, now I have no data, okay, let me go back to the event queue and replay all the events from the time when my data is lost. Okay, if all the data is lost, if no backup is kept, then you just have to go back to beginning of history and replay all the events. It will take some time, of course. You replay all the events and regenerate your orders. Right? Now, why can you do that? Because the only way you are actually creating your data is through either APIs that you got, which resulted in an event that you pushed into the queue. So your events are also there in the queue, or somebody else's events that you subscribe to, okay, resulted in a change in your data. So effectively, all changes to any piece of entity or data is kept in the event queue, and therefore it's called an event store also. There's no more just, we used to have RabbitMQ kind of queues or ActiveMQ, which were just purely queues. They did not do persistence. Okay, now new technologies like Kafka, for example, actually store, and you are able to have resilient stores of events. That's the big difference between using the old style queue and what we do now. Okay, that you actually persist events. And typically you have a window which is like 6 months to a year to say all events for 1 year are maintained in Kafka. So if a service goes down, okay, I can restore the backup for 1 year back and I can recreate all the data for the current year by just looking at the events. So therefore they are expendable. Right? Not only is the application expendable, even the database is expendable. So how do you use this? Now you built all the application, right? But somebody has to use these services. The way you use the services, the simple way is, of course, you write, responsive UI applications, and you have all the contracts of all the services available, and you use them. Now, the big problem, if whoever is written web applications, the biggest problem is there is no science behind usability. Right? However much design schools want to teach you usability is a science, there's a well-measured process of measuring how so-called user-friendliness is to be measured and how it's not a science. It's an empirical science. Empirical science means we don't know how people are going to behave. Okay, we'll push something out, measure it. If it is bad, we'll make a fix. That's empirical science. So physics is an empirical science. Mathematics is not an empirical science, right? Because you make an assumption and then you just go ahead. Physics is, let's do an experiment and figure out if it works. If it doesn't work, then we'll do something else. So usability is an empirical science, which means that UI has to be continuously changed. Constantly. You can't just rely and say, oh, now it is usable. The minute you start using the user, early days, the rate at which users had appetite for change was slow, right? So in fact, they complained to say, oh, the form is now looking different. Today, users complain if you don't make a change. They say, oh, it's getting boring now, right? So you have to make a change. You have to constantly look at how to improve the productivity of your application. For that kind of change, does it mean you keep changing all your services? Not necessarily. So what you do is, when you design your microservices, you keep in mind a generalized capability, right? So when you design a microservice, you want to try and maximize the number of use cases that it can address. But the UI doesn't want to bother about generalization. The UI wants to be very, very specific. Right? You say for mobile users, I want a completely different UI. Responsive UI is great. Okay? But what if I want to optimize it? I want to use native capabilities of the mobile phone. I want to be able to upload photos. You can't do that on the web. I want Siri support. I want voice support. All of these have to be done. You can't just wish them away. Okay. So then you say, hang on, for the mobile phone I need a mobile app, I need a different service. For the web I need a different service. And so you'll go back to your microservice and make a mess out of it. Okay. So it compromises the sanctity of your service if you start screwing up with UI optimization in your microservices. And that's why we introduce a layer called API gateway. What the API gateway, notice that the API gateway has the same color as the UI. Okay? Why is that? It's because people who design a microservice are not bothered about UI. They're going to say, these are generalized APIs. If you have a functional change in the API, tell me. Okay? If there is a way in which the business rule change, if the data model changes, then you tell me, I will go and make a change in my microservice. But you want to say that in the mobile phone, I want to show these two things together. So instead of these two APIs making two separate calls, can you just combine these two into one for me? Okay, sorry, that's not going to happen. Okay. Who will do that? The UI designer will do that. So UI app now should be able to have a mechanism that they can write UI optimized APIs for themselves. How can you do that? Because conventionally we consider UI to be, frameworks like Angular and React and jQuery and all that stuff, right? And UI developers consider themselves to be, more creative, all that stuff, right? And backend guys say, I'm a backend guy, I don't care about UI, right? Unfortunately, none of them are productive enough. But the problem is, if the UI guy needs to make a change, if he has to depend, because of this cultural mismatch, right? There are some people who consider themselves to be backend developers, some people who consider themselves to be UI developers because they think they are more creative. Now, the creative guy, the UI, should have a mechanism that they can define the kind of API that they want, as long as they are able to consume the generalized API and make changes on top of it. So, the API gateway typically should be something that a UI developer can make changes and define their own API. That's one of the reasons that we almost always insist that the API gateway should be possible to be customized using JavaScript. And therefore we use Node in the API gateway. So the function of the API gateway is to basically separate between generalized API and UI optimized APIs. And there are lots of patterns of optimization. So let's look at a quick overview of these three models. If you look at components, they moved from independently deployed, this is wrong. Independently deployed, that's the, I think I just copy pasted in the wrong way. Yeah. The first column is supposed to be this. No, where is it? This one. Libraries of reusable code, in-process calls, application logic, code documentation, single application, platform, to independently deployed services, tightly coupled messages, request response, orchestration was done with a service bus, interface definitions are discoverable, but strict contracts, technology stack is disparate but database is constant. Hopefully the last column here is okay. Services of reusable applications, publish subscribe events is intercomponent communication is now publish subscribe events, orchestration is through the event queue, interface definitions are discoverable, consumer. So there's a difference between subscriber driven, publisher driven contracts and consumer driven contracts. Remember we talked about the difference between generalized API and UI optimized APIs? Now you can actually have consumer, which is the UI defined APIs or contracts. Technology stack is completely independent, not only technology of application but even database can be independent, which is what we call as polyglot persistence. The polyglot is basically you can use multiple databases in the same application. Any questions so far? I'll quickly run through a case study of one application. I cannot tell you customer or it's just a simplified version of the application. This looks very simple, but it was way more complex than this. So just try to simplify it. Basically, the application is a large pharma company which had years and years of data relating to patents. Right? Pharma and chemical companies basically make money based on patents. So they create a new molecule. They have to research if there is a competitive molecule like that anywhere. And if they find that there is something which is different in what they have created, they'll file a patent. Okay? And then at some point there will be clinical trials and so on and so forth, and then finally the medicine will come out and they will start making money. So research of patents is a very core business proposition or business process in a pharma or a chemical company. And the volume of data that they process there is really, really large because you have to basically try and search all patents across the whole world. Right? If you create a new molecule, before you invest too much money in that new molecule, you have to first check whether somebody else has done that. And anywhere close to it. Because patents are such a complex construct that even if there is a partial overlap with the other patent, maybe all the investment you made in that new molecule is of waste. So their existing infrastructure was something like this. Basically, they had a lot of different front-end applications. They had dashboard, they had an intranet which was used by internal staff. They had a customer portal. So customer means basically they had different divisions, right? This is our client was the research division, and you had other divisions who were actually doing the molecule generation, and they used to say, go and search for this particular molecule and tell me if there is any competing patent. And so the customer was, the portal had a mechanism where the customer can come and put the data of their molecule and then get the results of their research. There was of course an admin panel. Now, the backend application was one large monolithic application of all different modules put together. All the files, the patent files, were kept in a sort of, not really a document database, but a file management. It's a distributed file management system. Very old. I don't know if you've heard of FileNet. So it's basically just a distributed file system. The actual document metadata was kept in a relation database. All the data that you see here was in one massive relation database. And it came to a point where the researchers, so the complexity in this application is the type of search you want. The search is not simple. If it was a simple database search, then maybe they could even stretch the life of this application more. The problem was that the search was a combination of a lot of relationships between patents. So one patent is related to another patent based on one attribute. That patent is related to another patent based on some other attribute. So if you want to find relationships, all these relationships, each relationship would require a SQL query. So typically when you fired one search, it resulted in almost like 50 to 100 SQL queries. Okay, that was really where the relation database completely failed. So if you look at the kind of performance they got in their legacy application, the average performance of search was 5 seconds. Now they had constant batch updates. Now what is a batch update? Basically you would get patent documents from outside and they had to be loaded in your system. And typically per week they used to get millions of such documents, right? And you can't load all of them at one time. So you had to spread them out in daily batches. And initially they started the batches very early in the morning, like 2 o'clock in the night, okay, and it used to get over by 8 o'clock, and so when people came in and started doing searches, the batch was over. But as the volume of data became more and more, from 8 o'clock it went to 9 o'clock to 10 o'clock to almost noon. Okay, so half the day was lost. And when a batch was running, the search performance went from 5 seconds to 15 seconds on an average. So because you're using the same relational database, right? So if you are doing a huge batch job on the relational database, your search performance is going to go for a toss. So what the customer said is, we don't know how to solve this problem. Okay, and they had some 3 or 4 vendors identified, and they gave a POC initially to say, here is sample data, okay, some I think 15 terabytes of data. Take this data, here are the queries that I want you to perform, and this is additional data which I'm going to give you, which you have to load in a batch. Okay, they had given some 3 or 4 different batch data. What we had to do was we have to show that and this benchmark was given to us, and this is the performance that we are getting currently for these queries. Okay, and we had to go and implement it and say, show me the performance of your queries. Run the batch and show me the performance of the same set of queries and tell, let's see what's the difference. Now, three companies were given paid POCs. And one company used Alfresco, the document management open source platform. The second company did a custom implementation using a relational database but with their own code. And we did it using a combination of this new architecture. I'll show you what we did. So what we did was we split up all the core services. Okay, and we create a microservice, we put an API gateway, we put an event queue. The most important thing, if you look at a tech stack here, you'll see that users, customers, projects were maintained in the relational database. Documents, workflow, collaboration was put in Mongo. The full text search was done using Elasticsearch. There's actually one missing here. We use Neo4j, it's a graph database for the relationship queries. And the analytics engine was Cassandra. Because we split this data and all the synchronization was done using events, okay? If you look at the kind of performance we got, search performance went from 5 seconds to less than 1 second consistently, irrespective of how complex the search was. When you ran a batch operation, by the way, the batch operation performance itself was 4 seconds per 100 documents, which went down to 1.5 seconds per 100 documents. But the most important thing is when a batch was running, there was absolutely no impact on search. Right? Absolutely none. There was no impact. You can run a batch for the whole day and search would still remain as fast as it was before. Of course, we went the order and we did the application. So that's a quick summary of what we have done in microservices and the model. I'll be happy to take any questions. Yes. Just give me a second.
So my question is based on RESTful API versus GraphQL. So can you tell me something about GraphQL on basis of RESTful API, because Facebook has implemented GraphQL and it has been documented where they found some problems in RESTful API where they were trying telling users to enforce the particular pattern which RESTful API has. But when it deals in a complex structure and it has a complex database search queries and all, so GraphQL was providing a flexibility. So can you elaborate on this point?
I don't think I understood your question really, but I'll try and interpret your question based on what I can answer. I think what you're asking is, first of all, you talk about GraphQL. So GraphQL is a query syntax that Facebook released to query its friend-of-friend relationships primarily, right? So you can basically, if in Facebook you have friends of friends, which is like a graph database, right? Or you have one person has 10 friends, each of those 10 have another 10, so you have a very complex graph. And then they introduced a graph query language where you can actually do a friend-of-friend graph traversal query. Now the problem with, so I think he talked about two keywords, one is GraphQL and one is REST API. So I'm trying to make sense out of these two, right? What is the problem in doing a graph query or any query for that matter? First of all, if it's a graph query, you need performance. And if a lot of people are making queries, so how do you do a traversal of a graph? Okay. First and foremost, if you store the data in a typical relational database, the way you would store a graph is each node is an entity which you put in an entity table. Okay. Each edge is basically a relationship, right? So you put a relationship, either you put a relationship table which does mapping between nodes. So if you want to do graph traversal in a relational database, what you have to do is you have to start from the first node. Tell me all friend of Shahid. Now you go to Shahid, search for Shahid, one SQL query. Okay, and or no, let me start with tell me all immediate friends of Shahid. So I look at the relationship table, get a list of all friends of Shahid, right? Then I go iterate over each friend and do the same query again. So effectively what you're doing is for doing a friend of friend traversal, you have to do a SQL query for each edge in the graph. Okay, and now imagine if you have somebody like Facebook who has millions of users who are making simultaneous queries, you will basically end up with a mess. It just won't work. The only way it will work is that you have an engine which allows you to do efficient graph queries, at the same level of infrastructure requirement as a small SQL query, a single SQL query. And a graph database allows you to do that because it basically just keeps the graph in memory and you can run it. So using a graph database solves one of the problems. The second problem is how do you get all the data out from a RESTful API? Okay, and so RESTful API will have limitations in terms of what is the amount of data you can transfer or you can return, and so you typically have to do iterative queries. So you run one query, you get one set. Now in a relational database, because your result sets are just one big list, okay, it's very simple, you can do pagination. But how do you do pagination in a graph? Okay, so it's not a trivial exercise. So you have to do some amount of iteration when you want to do RESTful APIs graph queries. I'm not sure I understood his question at all, so that's why I said.
Well, what he really asked is the difference of RESTful or GraphQL. So Facebook does come with this GraphQL thing where you can do the query, but if you want to use GraphQL along with RESTful API, there are some limitations. Which he asked, how we can.
I am not aware of what those limitations are.
I am not aware of the actual syntactical limitations of GraphQL, I'm afraid. Any other questions? Sorry, you had a question.
I actually have one question, but right now because of the previous explanation, I have one more question. How does the graph-based database store the data? I know how does a NoSQL and an RDBMS do, but I'm the first time hearing that.
It's actually very simple. A graph database stores the entire graph in memory. Okay, that's the only way you can make a graph query fast. Sorry? Yeah, so imagine, a graph is basically nothing but a linked list, right, in memory, right?
Yeah.
So you can create a graph in memory and it can be as efficient as you want. There, inefficiency is when you have to go into disk and to make a query for each graph traversal. So if I was to load the entire graph as a linked list in memory, then there is no problem, isn't it?
Yeah.
Okay. The problem is when the graph is really large, it doesn't fit in memory, that's when you get screwed.
Yeah.
So what graph databases do is basically distributes the graph across a cluster of nodes, but it keeps it in memory. So just look up graphics of Spark. It runs on Spark. Look at graphics. GraphX. So it uses Spark to run graph traversal algorithms. Any other question?
Yes.
We'll come back to you first in a second.
Yeah, I've got a question. Since you said if you're writing a microservice, that microservice will be consumed by the web developers, the front-end level, and the same microservice will be used by the person who's developing an app. Since you said not to write two different microservices if you're consuming, but there are certain keys which you are just throwing at the app level
but it's not required. The app person is saying we don't need that key value pair for a JSON structure.
Give me an actual example, then I'll try to make sense.
See, we are a private company, so when there is a product which we sell, so in each product there are certain things wherein you have the price, the number of days and nights, and there are certain keys like the places where we are taking, the region which we are covering, considering we are taking to 12 countries and 30 cities or whatever. So if that whole structure is there, but this whole structure will be at the front end level for the web. But for the app, we are not showing that cities and the countries part. It's an array, considering it's an array of elements. But that app person is saying he is not required because he is instructed not to bind that thing at the front end level. So if you want to write two things, there are certain things wherein, but the data will be thrown at the app level. So what will be the best way you will handle this kind of scenario?
So that's a good example. I think if you look at this model, let's say you had your query, backend microservice, which by default returned all data, right? Now the JSON payload is now going to be big, right? So mobile developer says this is too big for me, okay, it's not going to perform. So you split this into two services now, okay? You split it into two services or maybe three services or whatever it is, so that I can get whatever, only those attributes that I want in my screen. And because my screen is small, I can't fit all of this at one go. So what's the point in getting all the data at one go, right? So what do you do? Either you have to go and modify your microservice itself, right? And say, now I'm going to split and that means my web application will break, okay? Or you have to create a new API for actually the same thing, which doesn't make any sense. That's precisely the role of an API gateway. Okay. What you're doing in the API gateway is basically your backend service is consumed by the API gateway. The application or the web application not directly calling your microservice. You have an API gateway which defines a UI specific API. So you'll say, let's say, get product web, right?
Get product web or get product app.
Right? Get product web is one API that you define at the front end of the API gateway. At the back end, it is calling get product. Now both these APIs call the same API. Okay? The API gateway, you can do lots of smart things. You can do things like combination of multiple APIs into a single API, splitting one API into multiple API endpoints. You can do caching. You can do security, right? You can build security layer in the API gateway. You can do caching, right? So you can do a lot of stuff there. It depends on how much your UI developers are comfortable, right? So you can give a lot of facilities in the API gateway, which allows the UI developer to say, I want only to consume this. So in this scenario, if you had a proper API gateway, your microservices designer would never come into the picture. He's saying, is there a functional change? No. If there's no functional change, don't come to me. You want to create an API which is custom out of what is already available, you write your own API in the API gateway. Is that clear?
I have one experience with these same scenario. Can I share?
Sure.
So the same thing happened with us. We were developing the whole microservices thing, and our app was a hybrid application, right? So the same Angular code, little bit change, was running on mobile too. So the mobile developer said that the response JSON is way too big, and the parsing is taking time. So when the app is loading, it's taking a lot of time. So we had those options. So said, right, we can split the API and do that, but we were so lazy to do that. So what we did do, we detected hardware. So at the API gateway, we found out, from where the request is coming, and we just only looked for the mobile, and the rest of the guys are getting the same response. For the mobile, we just wrote one small middleware which is doing the change and returning the response. That worked for us.
But what do you use to write the API gateway? You just
Yeah, I use Node.js in the module. I can tell you the module for advanced detection tool. You can talk to me later. Okay. Any more questions? Okay, then we finish.
Can you take you to the stack which you showed, your tech stack for documents manager, right? Using MongoDB. Now, for the search, you use Elasticsearch engine. Now that Elasticsearch engine needs to do indexing every time. So technically, during the batch update, you're not getting the latest search results. So is it inconsistency?
Yeah. Frankly, if I have to really cover all the points in detail for microservices, an hour, I have already covered more than an hour, but typically it would take a couple of days. But let me answer that question. And that's a core issue, right? Why did we introduce event queue? We introduced event queue primarily to do synchronization between multiple services, right? Now, whether it is an atomic update or a batch update, all of them are treated as events. So the way a batch process works is not the conventional way where the batch process would directly call each of those services and say, you update the document, right? What we do is, there's a separate batch ingestion process, which is a service, which merely parses out the data, splits it into individual events, pushes them into a Kafka. Okay? Now, a new document has come into Kafka. Who will listen to it? The Elasticsearch listens to it, the Mongo listens to it, the user manager listens to it, whoever is interested will listen and simultaneously update themselves. So there is no offline synchronization. When the event happens, at that time, simultaneously all of them update their copy of the data. Right? And that's the most important reason why you need the event queue. If you didn't have an event queue, okay, it would be a huge mess because you would update one database, now you have to do synchronization, you have to do replication, you have to do incremental updates, God knows what mess we used to do earlier, right? So that's one of the reasons why if you don't have an event queue in your architecture, okay, you can actually completely screw up the whole architecture of your application by just splitting up into multiple units.
Can we use Redis instead of Kafka?
He asked, can you use Redis instead of Kafka? Yes and no. I think Redis has some limitations in terms of no, it does persistence, but it can't handle the volume of data that Kafka can. At least that's my impression. Redis was great as a pure queue. It's more like a caching server, more like a replacement for memcached-db. You use Redis, but
It's faster than Kafka.
sure, you ultimately, you have to figure out what is more important. We continue to use Redis, of course, for certain applications, but we don't use it as this event queue. We do use it for caching. We use it as a key value store many times, but not necessarily for an event queue.
The event queue log must be having some limitations, like you can't keep the
Yeah,
whole log.
we can discuss the event queue in more detail. Let's just give somebody else a chance.
What libraries you use for event sourcing?
I don't think we use any library. We use Kafka as the base, and
Kafka as just a message broker?
yeah, well, you can create topics and you can create multiple topics in Kafka, and you can use persist. You can define a window of persistence and you can persist all the messages in a topic. Any other question?
With API gateway, we can address the multiple hardware. So if that means if you can do very much things, like functional things in the API gateway. So like combining the service out from the so what is the limit? Like then if you do too much in the API gateway, then it will sound like too much like enterprise service bus.
That's a good idea. That's a good question. How much will you allow API gateway to how much functionality will you allow API gateway to do? Actually, there is no clear answer for that. The principle behind most architectural models today is to not necessarily make sure that everything is done neatly and tidily all the time. It is in certain scenarios, I'll give you some examples. Suppose a scenario happens that mobile application actually fails, right? It dies, it won't work. This is life and death situation. You can't have your mobile app start failing. Now, if the mobile app developer says, this is because the backend service is giving me too much data, okay? And I need to do something to the backend service to be able to consume it the way I want. You need to have the flexibility to allow him to do that, irrespective of whether it is merely a change in the data or in fact introducing new capabilities here. Right? He may say, no, now I have to add this new input in the form, okay, it's not supported by the backend API, I will in fact just store it somewhere on my own even. I'm taking a really worst case scenario, it should hopefully never happens that way, but even if that happens, the architectural model is not preventing you from doing that. Okay, one. Second, even if you end up doing that mess, okay, the idea is that there is a way to catch that situation. Okay, because the minute that happens, okay, you know that there is a change. Okay, it goes in your Jira as a story. Okay, it will be caught by somebody and say, there is something that needed to be done. It was done in this sprint. The next sprint, we are going to have time for the backend microservice to make the correct change and then deploy a new version. So the idea in new architectural models is not strict governance, right? The idea is evolution. See, the big difference between what has happened before in terms of, the big change from conventional architecture to new architecture is that we used to build software to last, right? We wrote something and we were very strict on how it was written, object-oriented, reusability, everything was done, and you have to think of all of these things before you write code. Today, you build software to change. The lifetime of any line of code you write today is so small that the last thing you have to worry about is it written the best way or no? Okay. If you ask an old fogey like me, all youngsters are writing extremely bad code. Okay. They don't think, because the architectural model allows you to make mistakes. Okay. And still push it into production, it still works. Okay. There are processes to catch it, automated testing is there so that it will get caught. So developer says, let it be. Anyway, it's going to get caught by the QA. Right? If you look at my code, I don't write bad code. I get really frustrated if I look at, that's why I stopped looking at other people's code. It's so frustrating that you don't have the discipline to write the code, but it's just a different generation. So bottom line is, when we had a small team, right? Jane has just come and she has worked with me for a long number of years. So those people, have been beaten into submission and they write good code. But you can't do that when you have 1,000 people organization. It's very difficult to keep that level of quality across a very, very large team. So the only way you can, and that's the real story of today's architecture. If you had a small team, whether you write monolithic or you write SOA or whatever, you can still do a good job. Right? Why new architectural models are important is because it allows bad programmers to write good code. If everybody was a good programmer, you don't even have to bother about architecture. That's the big problem. I hope I answered your question.
So I don't disagree with the event queue being as the most important part part over here, the single value of truth that you say. But I see a big data synchronization problem. Like, consider a situation where you have an offline first app. One person updating data will go and update one service, microservice. The other services will be eventually consistent. What happens if someone else goes and updates another service and then there's a clash? So the conflict resolution is another important part of having microservices. So how is that typically handled if you start going into a microservices kind of an architecture?
So let me rephrase your question a little bit. It looks like, if you draw a diagram like this, it looks like everybody is on all the time, right? And any event happens, simultaneously gets synchronized everywhere. I think the importance of your question is, what if some service is delayed for some reason, right? Let's say 20 orders happened in the front end, okay, and the inventory service was down. Now, what will the orders engine do? The orders engine will say, inventory, I don't have information about inventory, okay, or I have an old copy of the inventory because the inventory is not giving me any new event, isn't it? What happens in an inventory situation is, when a product gets consumed, means actually shipped, right? When it is shipped, inventory goes down, an event goes into the event queue. Orders database has to update its copy of inventory, saying for this product I have this, one less product. And so it doesn't allow a new order to be placed on that product, right? But suppose the inventory service was down, okay? So orders went on taking orders because it thought that there are, products are still around. So basically what happens is, if a service goes offline, okay, I'm reinterpreting your question, but the core question is the same. So I just want to give a more easy to understand scenario for everyone, that synchronization between services is not necessarily instant or immediate. Okay? There is a possibility that if a service goes down or is asynchronous, because events are basically asynchronous, right? So the big problem is, if you use events as a synchronization mechanism, if the service is not listening at all, okay, how do you ensure that there is no inconsistency between inventory data in the inventory service and the copy of inventory that the order is holding? Right? Effectively, that's the same end result of what scenario you described, isn't it?
I think the point here is the conflict resolution.
Exactly. What it is in, correct.
How do you handle conflict resolution?
Absolutely.
How do you know which is first and which should be given more priority?
Right. So now, in this scenario, effectively you've got a conflict, right? Basically, order database says that I have 20 pieces of a product. Inventory says I have only 10. How do you know which is right? Correct? So you will end up with situations where there is inconsistency between denormalized data. Because all the services are not necessarily listening simultaneously, they may not be alive all the time. And that's precisely the reason why you actually want the single source of truth to be only events and not the data. So synchronization means that, worst case, if there is any inconsistency, okay, I should be able to completely rebuild all my data by just looking at a sequence of events. So the only thing that you have to make sure is that your event queue is not down. Okay, you are moving your whole, single point of failure into the event queue, because the minute you treat the whole system as an event sourced system, your database is not a single source of truth, and your event has become a single source of truth. Irrespective of when the event was generated or when it is consumed, you are assuming that the events are always pushed into the event queue. So if there is any inconsistency, it will have to be treated on post-facto basis. Of course, you will have to treat with the inconsistency, right? It happens, forget microservices, look at conventional systems, distributed systems, like a bank, right? A bank is not, you can make a transaction anywhere you want, okay? And it is not making an online query to your bank to say, does he have enough balance? Isn't it? It allows you to make the transaction. And if when it does eventual consistency, it will find, oh, looks like he made a check and he didn't have enough balance. There is a mechanism you have to introduce now to say, if you made a check, there is a penalty, some process has to be there for you to take care of conflicts. You can't wish them away. You can't assume that in the normalized model, right, when you had fully consistent systems, you made sure that no transaction would happen unless you checked whether the balance is available or not.
But then in the first case, when it is a service model, the service bus became the bottleneck, all the complexity went there. Isn't the service bus now replaced by this conflict resolution system or something between?
Yeah, let me ask his question, rephrase his question. He's saying, in the SOA, the bottleneck became the service bus. Aren't we shifting the bottleneck now to the event queue? Yes and no. In terms of the single point of failure, yes, right? And therefore, you cannot use something like Redis, which is easy to fail. Why Kafka is more resilient is because underlying it can use automatically replicated data. You can scale it out to as many copies as you want, so that there is more resilience in the event stream. That's why it is slower, in fact, right? That it actually does internal replication. It can use HDFS at the bottom for storage. All those kind of good things, right? But it's slower. So yes, you have shifted the single point of failure in terms of infrastructure failure. But the infrastructure failure has several mechanisms to overcome those drawbacks, right? Like replication, for example. What you have not done is you have not made the functional failure in events. It is an infrastructure single point of failure, but not functional single point of failure. Because event queue is dumb. It has no intelligence in it. You don't have to write a single line of code on Kafka itself. Kafka is just an engine. You just push events and it pushes out events. So the big problem in ESB was not that it is physical, not only is a physical point of failure, it's also a functional point of failure, because you can't even make changes in your application till the guy who's writing code in the ESB makes a change. So yes, physical point of failure has shifted from ESB to event queue, but not functional point of failure. Did I address your question? Yeah, sure. Any other questions? Thank you. Thanks, everyone.
Thank you, sir. All right. The next talk is on cloud resource optimization. So, all right, go ahead.
बीच में से
जैसे 2 बार ऐसे तो पुश करेंगे ना 2 times. मीटिंग में दिख रहा है you need to present your audio. Right side or left side?
Hi everyone.
आवाज आ रही है?
I'm going to present on cloud resource optimization. We have developed a product called Accion on that, and I'm going to explain how it works. So what?
Hello.
Hi everyone.
Near to.
Hello.
Yeah.
Today we will talk about cloud resource optimization, and we have developed a product called Accion for that. So we'll see how we developed the solution for that. So we'll start with a basic business problem. How did we discover this thing, and what solution do we present, and how one of the solutions which we have developed, tech stack, our current limitation, and what is our future with that. So current business problem. So previously, when we developed the application, we had to test the application beforehand, and we have to procure the hardware required. We had to procure the hardware upfront, like what all RAM you need and CPU process. That was done by a team, operations team. They had to do all the capacity planning and performance testing, which showed like what all you need to procure. So this was a very lengthy process and a very hectic one. And we capacity planning was also a very tedious process. They had they had to write bunch of scripts and orchestrate various hardwares to do that. So
Mike.
Hello. Hello.
Hello, can you hear me now? Everyone?
Like, no?
Switch the mic.
That was the old.
Hello.
Yes.
So what previous I'm starting it again, so I'm not sure I have to record it. So what previously used to happen is when in a traditional model, when you developed an application, you had to do the capacity planning, like how much hardware do you require for CPU, RAM and all, and you had to do the performance test of your application, and you had to procure the hardware. This was a very lengthy process, about 6 months or so. People used to order it in advance. So then that department was outsourced to other people, and they used to manage all this maintenance of the hardware, and this is what we call it as a cloud. Basically, from buying we went to renting. And capacity planning was also very limited. It was done in a very, people used to do it, but it wasn't so effective. So now that we have our hardware at our disposal, cloud, the capacity planning was eliminated. They didn't find the need to do that because they can rent the hardware anytime they want with a few clicks. So we don't think so. That's the thing. We still need to do capacity planning for cloud, and these are the following reasons why: elasticity.
So initially when you design your application, it doesn't mean it is automatically scalable. And when you deploy it on cloud, you still need to see that your resources are growing at the right moment and shrinking down if you don't need it. If this is not happening, then it is costing you. Second is in architecture. When you design application when your business was small, the architecture was really simple. It wasn't that complicated. But when the business needs started to grow, there was more and more components that started getting added to the architecture, and this was complicating the whole thing. And we had to make sure that there is no non-scalable component. So for that we need to do capacity planning. So that we can ahead of time we know that there is something like that which we need to that needs to be taken care of. Another was cost reduction. The resources which you are buying, you have to pay for that. So if you have an option to maximize the utilization and minimize the price by removing unused resources, then why wouldn't you do so? So you can get rough estimation by doing capacity planning there. Another thing is pricing and budgeting. When you have, suppose for scenario, you have an e-commerce application, and you are running your application on normal days, you have a fairly predictable load. But when you have a sale, then you should be ready for that, and your business team should be know that what all it's going to cost you when there is a bursty traffic or some unusual thing is happening. Then selecting the cloud provider. There are many cloud providers in the market. They have different pricing scheme and different features they offer. So you have to make sure that the architecture which you have developed can be deployed on that cloud service. It has all the features which you need. And management is like when your business starts growing, the architecture is getting complicated and new things add. When it is getting at very high scale, you have to make sure that you are able to manage that. And by doing all this capacity planning on all these levels, you get a rough idea and rough numbers like what you need. So what solution we propose is when there is a software development, when there is every release cycle, you do a basic performance testing, a basic functional test, like the application is actually working the way it was supposed to. Then you move. Then from your past experience of your application, you get a rough idea like I will need so and so resources. So let's try that performance test on those resources and we deploy it. So that was done in a manual way, manual capacity planning way. So what we suppose is what we are trying to say is why don't we automate that? As I was when this whole thing was done, till the functional test was done through CI/CD process. You have a code release cycle, you have automated testing running on, then you do basic functional tests and your code is deployed. Why don't we integrate the performance testing and capacity planning in the CI/CD process? Suppose there was a way like your CI/CD process could tell that this new code need to run on T2 large instance rather than which you were running previously, T2 medium. That will reduce the load on our side and we can focus more on business logic. So we have implemented a solution for this process which we said. So first of all, you have what input are required to our system is API specifications which are documented by some API documentation tool. We have considered Swagger. And AWS, we are using AWS as our cloud provider. And input which you are expecting is what requests per second do you want? Is it 10,000, 50,000? What are you expecting? And what resource threshold is like, I don't want my server to cross 80% in peak load. So once you give all those input to Accion, it does the basic instance setup. Like AWS doesn't give you memory, RAM consumption. They only give you CPU and network and disk. So we also needed the RAM. So we had to install a bunch of script and make sure that we are getting the RAM metrics. All these logs are sent to the CloudWatch. So we are using CloudWatch service provided by AWS. AWS had actually a lot of features. We can do anything with their APIs, deployments, installation. So AWS was the choice. Then we perform a basic functional test that your application is still doing what it's supposed to be. When we start doing the performance test, the first performance test is just to know that what kind of application your application is. Is it CPU intensive? Is it RAM? Is it network demand or disk intensive? So if you have a database server, it's a very RAM and disk intensive, and if you have some computation going on, then it's definitely going to consume more CPU. So first performance test is just to get the idea that it's what kind of server is. Then we try different AWS instance, and we gather the resource metrics, like what is it's actually consuming, and then we upgrade the resource. Now the trick here is like what instance should I upgrade and how should I plan on doing instance testing. Now we know the basic flow, like we do performance tests, we gather the data and try another instance. But there are family of instances which are offered by AWS, like general purpose, which is a balance of CPU, RAM, network. You usually start with that. Then there is a family of CPU instances that are very CPU intensive servers can be deployed on that. Then network, the category which you see over here, they are family of instances are given by. We can't try in all that. There are more than 100 type of instances. So what we did was, initially we tested your application on a general purpose instance. We generated enough load and gathered enough data so that we could decide what kind of instance your application is. What kind of application you are in. Is it CPU, RAM or network? So once we have decided that it's a CPU, we try all the C4 large, CX large and C2 large. And the next step is we want to make sure that that instance is giving your requested performance. So if you wanted 10,000 requests per second, we tried all the instance and which instance is giving 10,000 requests, and that's the final output of Accion. It goes ahead and set that instance as C4 large. So what tech stack front end is Angular, HTML, and the main magic is done by Node.js, and we have load generation bots which do load generation, and we have also integrated it with Jenkins, so it is completely REST API based. So we have made UI so that we can help people to get started with it, but the main idea is to integrate it with Jenkins. So we have made it completely API based. So let me show you the website, the product. So here is the form which, as you can see, you can enter the name of the test suite and the host which you want to test. This is the maximum request per second you are expecting now. So it can be 10,000. Right now it is limited to 1,000 per second, but we are upgrading it. So resource constraint, which I was telling you, that you don't want your instance to cross a particular limit even in its peak hour. So this is that resource constraint. You can import, if your APIs are documented in Swagger, you can import that Swagger file. The whole UI will be pre-populated. These are the AWS secret keys and instance ID which does help us to auto upgrade and all. If your API is behind any authentication, and here you provide the API specification, like what path you are trying to test, headers, query. This is all standard API thing. So like to import a Swagger so you can get the idea. So once you import the Swagger, as you can see, you have all the APIs. You had the host on which it is hosted, the API specifications. It has all the Swagger has an example file, so we have put that data as well. And you can submit the test. We also have to fill the AWS details while have a pre-filled form. So these are the AWS details which you might be having on your system. So once you submit the test, you can see the running test in the report section. I'm not sure if that's what I'm doing. So we had one project Accion, which was an airline system. So as you can see, it first tested on T2 micro, and we did not get any minimum RPS. General type system failed on T2 micro. We tested all this API, and maximum RPS was given by, so it basic functional could not cross the basic functional test. So if we dig deeper into it, we'll get why it failed. Like some of the connection were reset of. We also show this also shows you the resource graph, like how much CPU was consumed during that, and how much memory was consumed during that test. And here is the overall graph of the whole test suite which you had done. I think there's a better report we have. So in this T2 medium, we see that we got a maximum request per second for this API as 10, 100. 100 was the requested API. So as you can see that it passed all the tests, and here is the overall resource graph. Over here we can see that beyond a limit, memory was constantly consumed, and the more of CPU was consumed. So we know that it was a CPU intense application. And this is the concurrency overall request. What was the response time of the overall API? We also tested it on T2 large, and you also have the option that if you want to downgrade your instance from T2 large to T2 medium, if you think the price is too much. Over here you can see we also fetch the price from the AWS APIs. Like this costs you about $0.094 per hour, and you can budget that accordingly. This can be the entire thing which you have seen right now. You can get the data from the REST-based API. So, and in your Jenkins pipeline, you can write a logic, like if you want to compromise your request per second to lower instance with that is in your budget, then you can do with this. Anyone has any question till now? So what are the current limitations of the Accion?
So this is about just running it for a test suite. Is it possible to run this in production and to check whether the instances which you are running, can they be improved by downsizing or upgrading the instance?
Yes, you won't be touching your production instance because this upgrades your instance, downgrade your instances. So that might affect your service. We create another temporary server, so which tells us.
But is it possible to run this and try it on?
Yes, yes.
If only thing is service might go down. So if we have a rolling update kind of thing, then this might work, right?
Yes. So you just have to give the AWS details, like your API keys and instance ID can run on any server.
So I think his question is that what you're doing here is before you deploy the application, you check what is the best configuration of the infrastructure to be able to match the load you expect. I think his question is important that after deployment of the application, suppose whatever you predicted before is not true, right? How do you know that your application is able to handle an optimal infrastructure configuration as such? Today what happens is, what we do is we set the auto-scaling configuration, right? So assume that your maximum load is 10,000 and per instance you got from here was, let's say, 1,000. You would create an auto-scaling configuration of 1 to 10. But the limitation of auto-scaling is that it is only nx. So what if instead of auto-scaling, you could actually say, put one T2 large and one T2 medium. You can't do that in auto-scaling, right? So, and that will reduce your cost. So if your load went just beyond one instance, let's say, right? What you would have to do is to create one more T2 large, because that's the only way you can create an auto-scaling configuration, which effectively doubles your cost per month. But if your additional loads was just, say, 20% of your capacity per instance, actually you could have just put a T2 small or something like that, to take care of the additional load. So I think his question is absolutely right. And it's important for us to be able to monitor the live load per se. That is not what the application is designed for. But if you look at the second half of the application, which is one side is actually creating the instances and doing the performance test. But the second side is the feedback, right? We are monitoring resources of the application. We are generating load, and we are also monitoring it. So theoretically, it should be possible for us that if we separate out only the monitoring part of this application and put it on a live system, where you have defined your limits and say, per instance, based on my initial capacity planning, my maximum load per instance should be, say, 1,000. If the load goes beyond 1,000, okay, if it goes beyond 2,000, then you create 1 plus 1. If it goes 1,200, then you just create a different configuration altogether. So I think it's a very important question. Currently, the system doesn't do that, but I think that capability is there in the basic logic per se.
Are you looking for performance or performance per dollar?
So performance is, first of all, defined in terms of latency. So when we say that APIs have to have a certain performance, you just say that, I can't afford anything more than, let's say, 3 seconds latency for any API. So what Munawar is doing is he is basically making sure that if you define your latency, maximum latency as 3 seconds, if that instance is not able to give you for the amount of requests per second, if it's going beyond 3 seconds, it will upgrade. So cost is the least possible infrastructure which will give you your required latency.
So you can see that graph, the cost versus the concurrency which you were asking. So this gives you request per second and what was the price for that instance. If you see from T2 micro, it was very less, And if you T2 medium, it went little ahead, and T2 large was too much. So currently we are only supporting single server application in which you have your database, everything in one server. And we are only supporting AWS, and we are looking forward to integrate other cloud providers. And test suite is sequence, like it takes like 12 hours to complete one test suite. So we are parallelizing that so we can improve on time consumption. And load generation is, as we had seen previously, 1000 requests per second. But we can use AWS Lambda to generate millions of requests per second on demand. So what is the future of this product? So it's going to be supporting other cloud providers, and comparative cost of infrastructure, like you requested 1 million requests per second. What will it cost on any other cloud providers and AWS? And like digital, how much will it cost on DigitalOcean, AWS, and Azure, and etc. Scenario-based performance testing right now, which we as we have seen, we are testing each API as one. But in a real life scenario, you have scenario-based, like in sale. A user is buying a product, adding it to cart, making the payment, and logging out. So this whole scenario has to be tested, and that's how it should be. And support for have very high load generation. Thank you. And any questions?
Can we use this product? Like, is there a trial period?
Yeah. You can contact us. Perfection.com is also working.
So we can sign up there?
Yes.
Without trial period or something?
Yeah.
Yeah, so just going back to some of the discussions around the questions, what if you could use this software to just say that you're actually running a much larger machine than what you should be, so it gives active recommendations on live applications.
Yes, we are. Once we have the data, we can run all the data algorithm on that.
Okay, so if I've got a list of 10, 20 instances I'm using, you could actually give live recommendations that you could have saved X amount.
Yes.
By just
Instead of doing just at an instance level, is it possible to do the thing on a service level? So instead of running like 5 medium, if I downgrade to like 10 small, will it be more effective? So right now what you're doing is, I see that whenever it reaches a limit, you try to upgrade it. But that may not be the best solution. Sometimes I have a really high load in the morning and may not have the evening. So instead of running 3 medium, I can run 10 small and get better manage.
Yeah, we are still trying to introduce more intelligence into the product. So right now we are just testing single server application, as you can see, but in real life there is a distributed server. We have to gather logs from all the data, all the servers, and merge them to create some intelligent, some data that we can work on. So we are still working on that.
Yeah, good product though.
Thank you.
Any more questions? Okay, next one. Okay, so the next talk is on TypeScript. I think with release of Angular 2, most of you are actually getting familiar with. So let's see what we with Pankaj. You may lower your sound.
Pankaj and hello. 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 Yeah. So hello everyone, myself Pankaj and I'm going to give a small talk on introduction of to TypeScript and so I work at TSS Consultancy Private Limited in Lower Parel, and there is my social media details if you wanted to reach to me. And yeah. So before proceed, you should come to know like who I am and why should you listen to me. So see, I love to code in .NET. So basically, I work on a Microsoft platform on Microsoft platform on backend, and for front end I use Angular. So I have 4 years of experience total, and so I'm active. I actively contribute to Angular community. If you I usually contribute via Stack Overflow and sometimes GitHub. Regarding that, in last year only I got rewarded by Microsoft with the MVP award in July. So, and thereafter, if you visit a Stack Overflow top users, so I belongs to top 25 users, top users from India, and for Angular 1 and Angular 2, I belongs to top 10 users. And because of that, Angular team has invited me twice, this year and last year, for NGCon, which is an official Angular con. So, but the thing is, I won't be able to make it happen because of my visa rejections. Yeah. And there is many more, but this is what I can brief about. So, in this talk, what I'm going to cover is these topics like TypeScript, what, why, how to use it, how to make it work. There will be a little demo, and then we will try to cover up fundamentals like small topics. But I got a really less time, like 45 minutes, so I will try to cover as much as I can with the TypeScript fundamentals. So basically, we will concentrate on the first 5 points, so that you will get familiar with TypeScript, and after the demo, I will be sure that you can do something with the TypeScript at your home. So yeah. So first, understand what is TypeScript. So in JavaScript, what happens is when it comes to how can I see, take an example of first tell me how many of you are backend developer like Java and C#, who deals with OOP. Yeah, okay. So sounds good. Yeah. So if someone told me when I was 2 years back, I was usually work on a .NET, and like apparently some project got switched, and I tend to work on the JavaScript part. So what I used to struggle with the types, because the weird thing about the JavaScript, not a weird I can say, but when I was working on a server side, I felt that when it comes to like variable assignment, suppose I declared a variable like variable test is equal to a string value something, and thereafter sometime after in my code only I can change the variable assignment to some other object. So that leads me to a different confusion. Like what I was working on a server side, that was very different than what is I'm doing on server side, client side. So first look at what is a TypeScript. So TypeScript is this is not a new language. TypeScript, it is providing a little kind of interface over a current JavaScript. So if you can see, there is one circle, and inside that there is a today.js. Today.js in the sense which is a ES5 version. And recently, 3 months back, they launched ES6 version. And over that, TypeScript has some feature, so that is nothing but a typing. Why the name is TypeScript? Because it comes with a type, like we use on a server side. Like, so let's look at the definition first. TypeScript is a type superset of the JavaScript that compiles to a plain JavaScript. And any browser and any host and any OS, what that does mean is, like, you can write a code in a TypeScript. There is a particular syntactical syntax to write a TypeScript like C#, Java. You have to do it in a particular way. That will, what will happen when you compile it? When you compile it, it will transpile down to a JavaScript only. So basically, all the browsers know JavaScript. So you are not going to refer, like if you wanted to write some code in a TypeScript. So yeah. So when you write some code in the TypeScript, so what will happen is, you are going to provide that TypeScript link to, on your HTML page, so that JavaScript would work. So internally, what happens is TypeScript compiler, takes that TS file and transpile it to a JS file. So move on. Let's cover this part later point. Just first we will, take on, we will cover this part more in a demo so that you will understand more about what is the TypeScript part. So first let's, you must be thinking like, why TypeScript? Why I should go for a TypeScript? I have a JavaScript. I have good skills and good hands-on on the JavaScript. So this is a few points which I thought about and I wrote it. So very good thing about the JavaScript that has a dynamic typing. What does that dynamic typing meaning? So if you assign, if you declare a variable and if you assign any value to it, that variable becomes of that type. Okay. So and the good point about that is variable can hold any type of object value. You can assign any object value to a variable when you declare it. And the second point is types are determined on the fly. So when variable don't have any value, it is of type of undefined. If you do a type of on that particular variable, but as soon as you assign a value to that variable and then you do a type of, you can see the type of can be a string. If you assign a string value, that type can be any particular object or blah blah. So the third thing is implicit type conversion. When comparisons comes into a picture, like when we are comparing values, like suppose I have a variable A which has a value 1 and I have a variable B which has a value 1 in a string, like single quote. And if I compare A with B, A equal to B, so what will happen in case of the comparison when there is a double equal to? In that case, internally their implicit casting happens. That's why it comes to a point where that expression becomes true. So for that reason, you have to to make sure that it should be of type of number. So that you have to use a triple equal to. Triple equal to is the check operation with its data type. So generally this triple equal to operation isn't there in server side. So server side people are they are less sure about it. So that's why I had it in a bad point. And the other point is difficult to ensure which method should return which type without return testing. So basically whenever it comes to a JavaScript, so we write a test cases using Jasmine test cases suite, or it can be a Karma Jasmine. So in that test case, what we ensure is we test our code using a test cases. Okay. So in that test cases, that can be a behavioral test case, a behavioral testing, or a model. Test driven. So basically, when we write a JavaScript, so we slice down our big file into a smaller function, and we write a connecting one function, like we write a function which connects to all the function, and we call whatever our actions are. So like yeah. So yeah. So to make sure that if suppose I am a developer who is working on a project A, and since last 1 year I am working on that project A, and I know each and everything, like input and output of that project. So sometimes after I put it on my paper, and there is one guy is going to replace me in 2 days. So in that case, it is very difficult to do a KTs in 2 days and all. So that kind of reason you can compare with the test cases. So what test cases does is, that test each function of your JavaScript or whatever your program is, and it provides one input and expects some output. So what happens is generally what people do is they put their test cases suite on before when you push it to when you ship it to production. So before that it should run, and all the test cases should get passed, and then we will we will deploy our code to whatever the production whatever the environment it is. So that kind of thing takes time. And what TypeScript does is, if you look at a TypeScript, it has a strict type assigned to it. Like if for each variable you can give a type to it. Like suppose if there is a variable a, and I said that variable a is equal to something. So what happens is that variable a holds a string type of that variable type becomes a string. Okay, so that is called as type equivalence. So we will come to that point in the next slide. Can I get a water? Yeah. So So now suppose I wanted to suppose client gave a new requirement, and on that requirement I am supposed to work on that. So in that case I decided that I will use a plain old JavaScript to make a POC of that project. So what I did is I use a plain a JavaScript which is ES5 current version, and I made it such a way that I can give that POC to my client. And thereafter what happened is client approved that POC, and again the all guys which came to my team, like 5 guys got selected for that, and they started work on. And initially what I did, I finalized the JavaScript. I'm going to use the JavaScript for our project. So we started an application without decided particular design pattern which we are going to do and all. So after some time, when it becomes to large application, this is what had happened. So if any new developer comes in, then he will not able to define that where my particular code is. Like suppose my application has one sub module called as calculator, and that calculator has many methods like add, multiply and all. So he will not be able to decide if it is a calculator, then when should I look into and all. So basically I haven't when I created my application, that time I haven't really put a time on what design should I follow, how modular I should make it and all. So by using a TypeScript you will get this. Basically when it comes to a TypeScript, the server side developer they have some module patterns called as there are many patterns like I can say design patterns which are repository pattern or module pattern and all. So basically when you are from server side like .NET, Java, Ruby and PHP, you are more familiar with type. And so basically whenever you define any variable, you define its type with it. Like suppose I am retrieving a record from a employee table, and I'm going to query my C# code.
You say pattern, right?
Yeah.
Which pattern?
Yeah. So in this slide, okay.
You said it comes with JavaScript patterns. I mean, there are plenty of them, right? Adapter, prototype, concurrent.
Yeah. So basically, what I meant to say in that point is, when I started my project, when I came, one POC got approved from a client. So then, at that time, I haven't spent much time on the which pattern or which module, how to make my code modularized and all. So directly I started working on it, and so by that time what has happened? 5 developers are not maintaining a code in such a way that they are they are following such pattern. Like in JavaScript there is called as revealing module pattern, and or generally that we people follow that, or in that case we follow one kind of architecture, and we generally have one variable which can be act as a namespace. Like if we decided to, yeah, that comes by design. Like if we are following that in design, so if I didn't do that, then this kind of thing will happen. You got it.
So basically, we have to follow pattern. TypeScript doesn't force us to follow patterns.
Yeah, TypeScript. What TypeScript do is you don't need to learn that much to it will internally maintain a code in a such a way that you don't need to learn a patterns. It will, when it gets transpiled to a JS, it will has that. It will have common JS pattern. I mean common JS module. I mean it will use that module loader kind of thing. Yeah, you got.
We'll come back to it.
Okay. Okay. Yeah. So okay. So developer moving from a client side, server side to client side, they usually face such kind of problem related to types. Like when they declare any variable, sometimes it initially it has a value string, and after some time we can change it to something else, and which is not correct if you are from if you are from seeing it from a server side point of view. So basically what has happened, Microsoft has came up with a TypeScript in 2012. So what problem they had is they had a more server side developer, and they wanted them to work on a JavaScript side. So they thought that, so all the developers who come to JavaScript platform, they aren't aware of they don't really like a dynamic typing. So what Microsoft did is they internally developed one kind of tooling system or a language which by which they can write the code in a C# way, and that gets transferred to a JavaScript file. So basically Microsoft did that for that purpose, but thereafter it got maturized by they made it open source, and many people got interact with that, and it got maturized in such a way that it become more modularized, and currently many framework are using it as in like their core framework has been developed on TypeScript only, like Angular 2 and other React also has its that component what I can say, they have a decorator called for a type. They have developed that in a TypeScript, and we can use it to modularize our code. So basically, yeah. So how TypeScript compiler works? So that TypeScript compiler, whatever we have a file, like it has to have a TS extension, okay? And what it does is it takes an TS file as an input, and that TypeScript compiler takes it, and initially on initial phase we provided some configuration. Based on that configuration, it transpiled that TS file to a JavaScript file. Okay, so the TS configuration will have which module to be, like in current case we can transpile it to ES3 or ES5 or ES6. These three options are available. And while it comes to a module, which module pattern you can use, like it can be a common JS pattern, or there is one more system.js or AM and other. Yeah.
So I do have a question here is, if you say it transpiled,
Yeah.
so it's transpiled to ECMAScript to O3. So browser is already doing that. We don't need to compile it. And the biggest disadvantage I see here using a TypeScript is, so you compile it, you are adding a dependency on a compiler. ECMAScript is all the browser are right now standard, following a standard which is made by some browser render. So those standards are being followed. Okay, so ECMAScript 5 has been continuously evaluating and integrating with the browser, and after that it's been shifted to a browser. So there is no compiler in the middle. So we write
So basically, your question is, it is overhead to, you mean it is overhead to why I should write in a TypeScript and it should get compiled into a JavaScript. Yeah, yeah, yeah. So basically, you can have plain JavaScript inside a TS file as well. If you don't want to. Yeah. Yes. So see, what TypeScript will do is, it has a, yeah, it has a static typing which will help you to resolve issue such kind, like take I will give you an example. Suppose I have one method which handle error. So error handler method, suppose, and in each HTTP call rejection I have that method. Okay, and in that method what I did is I did whatever error object I am getting dot exception dot message, okay, something like that. So in that case, suppose what I did is, when error gets pop up, when error gets from server side, when error happens, that method gets called, and from that method I pop up the error with error dot exception dot message. So what we yeah, let me complete it. Yeah. So in that case, suppose I made a mistake in the exception is object, and inside that message is a property of that particular object. So in that case, I made a mistake where I did that error dot exception and the dot message ka m is small. Okay. So what has happened? I came to that point and I suddenly I realized that error comes up which is undefined. So over here what I did is I spent time in this case, when error pops up, I didn't able to know, like, for getting that, what that property is, I need to, ask a server guy, what was the error message, or I need to look into message ka, what I can say, for network to message ka response, that error message response, and I will check that, and thereafter I will change that property. So, yeah.
So generally the code we write, we have the build process.
Yeah.
So when we are basically running our JavaScript code, whether server side or the UI side, I do the static type checking.
Yeah.
I do the all the code refactoration checking. I do the sonar checking, and then my code runs. Do I still need TypeScript after that?
No. I mean.
Do I?
Yeah. So in that case, you see, the TypeScript. I mean, TypeScript is an optional. Like, if you don't want to spend most of the time on deciding which pattern to follow and which, I mean, it's such kind of error, like what I said, in this case, I could have used JavaScript only, and I could have looked at it to network console, and I changed my property exception dot message m small to capital M. So in that case, if you have something called as, what I can do in my case with a TypeScript, error will have an object. Error will be using an interface called as error colon, whatever the exception object is. So in that exception object, you will see that that exception object has particular object structure, and it will have a message property in it. So so we will cover this part more in a demo thing. So let's move on. Yeah. So how to use a TypeScript? So in this yeah. So it is a Microsoft thing, so it has a plugin to install .exe file for Visual Studio 2013 and 2015, but I would not concentrate on that, but I will demo you through the VS Code. So VS Code or any plugin like Atom or Bracket or anything, with that you can use that. Just you need to install a TypeScript package from npm, yeah. So what we can do is we can take a look at a demo so that we can So I'm navigating to my folder and yeah. So here I created one folder which is Meetup, and inside that I'm going to create my project folder which is DigitalOcean. Yeah, and now I'm going to open my Visual Studio Code using this command, but this doesn't work. So for this you have to enable this command. You should install this vs.code command into your Visual Studio first. So you can press Control Shift F, Control Shift P. And over here you can see there is install code command path. So I intentionally included this thing because you will also face this issue with while using it. So now you can restart your Visual Studio and you can see that this command is working. So what it will do is it will open a current folder into Visual Studio. So this is a Visual Studio code. So over here what you can see is here I opened a DigitalOcean folder and that has nothing. So what I'm gonna do is I will be creating a new file. I'm not able to how can I type it?
Okay. I don't know.
So yeah, I created one file called as app.ts and yeah. So that file, the file extension is ts, and I made that file. So just as I said before, if you wanted to migrate your application to TypeScript, so first what you can do. TypeScript also allows you to inject, allows you to have ES5 version of JavaScript. That means current JavaScript version. So let's try to make some ES5 code, like just have a console.log statement. So JavaScript works. Okay. So this is my app.ts. Now what I will do is I will install. As I said, as I shown in my slide, I need to install npm package called as TypeScript to my current folder, to my machine. So basically, what I will do, I am on the same folder. I will do npm. So TypeScript got installed. So once TypeScript got installed, you will see the TypeScript version over here. So which is nothing but 2.1.6, which is the latest one. Or even if you wanted to specifically check it once again, you can do TypeScript -v -version. Yeah, TSC, sorry. So or the normal V as well. Okay. So currently you are on 2.1.6 version. So see, now I wrote a TypeScript file, and as I said, what TypeScript compiler does is it takes a TypeScript file as its input, and it generates and it creates a JavaScript file, and that JavaScript file you can refer on the browser to your JavaScript play into the picture. So how can you do that? So basically for that, TSC is the command, which is a TypeScript compiler, stands for TypeScript compiler, and there you could provide a multiple options saying that I wanted to compile this app.ts to suppose if I wanted to compile it to ES5, which is the current JavaScript version. So I can say target ES5. With that, so let's start with this one first, and let's see what happens. So if you look at if I do ls, I can see there are two files. What TypeScript compiler does is on the fly, it when I run a command, it look for app.ts and it converted into a ES5 version. So if I open this one, so I can see the app.ts is, the whatever it has, app.ts, that got transferred to app.js. Yeah. So suppose if I have one more function, and if I check app.js once again, see. So that means TypeScript can run ES5 version as well as and its own new syntax, like which we are going to look into now. Yeah. So now let's define one class of a TypeScript. So here, I defined one class hello world. Each class has its constructor. So see, as soon as I type in, it is providing me IntelliSense, which is why TypeScript is a great. In most of the time while we are developing a JavaScript, we do mistake in like typos in function names and all. So here you are going to get a IntelliSense by TypeScript. So suppose I defined one more. So what I'm doing is I'm editing a TS file. Inside that I wrote one class which is a hello world, and inside that I'm defining one more property called as name, and then I'm providing a type called a string. So see, I defined one property which has a type string, and so now I'm going to create an object of this method hello world, which I can do in server side language, server side language also we can do. In C# also we can do a newing that particular class, and then see if I do hello world dot, so it is giving me a hint that name property also exists, which is of type string. So I can do and I can console that particular property. Now let's transpile this file. Within a second it will. So now I wanted to run it. So what I can use is, I can use a node. I can use a node to run a file. So what will happen is, it has printed a console.log with a console.log with undefined because we haven't really assigned a property to anything. So what I can do is I can expect one parameter inside a constructor of my hello world class, which can be a name only. I will be defining as a type of string. So see, here it is showing an error. So it is saying that supplied parameters do not match any signature of that call target. So this is what the TypeScript comes into very into picture. If you are using a plain JavaScript, in that case you wouldn't have get this error. You have to compile it and then you would have checked your console. There is an error regarding something. So here it directly says that I need to pass one property string to it. So this type of error you got in compile time only. So this is big like time saving thing. So here I passed it. So here it was hello. Yeah, here it was duplicate identifier. Hello world.
Spelling typo mistake. Hello world.
Yeah, now it is fine.
There's a D missing.
No, I recompiled it. So yeah, this is the way you can do it, but you can set up a task as well, that will happen on the build time. You just need to press a control B to run a task in a Visual Studio. So for that, what you can do is press control shift P for this command like to get a command line, and here you can say run build task. So as soon as you run a run build task, here it said that like you haven't configured any task runner. So you have to configure something. So I clicked on that and it provided me few options. So from there I'm going to select the type state. So over here, so I got as soon as I clicked on it, it added a task.json inside my folder, my current workspace, which is a .vs code. And inside that task.json has been appeared. So over here it has a particular structure of what I can say. It has a particular object configuration. So over here version is nothing but whatever you can give. In command I have been specified TSC, which needs to be run on the command line terminal. And thereafter these are the arguments which you should pass into your after your command. So here what I'm going to do is whatever I wrote directly inside my terminal, so I'm going to specify them over here. Like it can be TSC, not TSC, it can be, first thing will be a target with double hyphen. The target can be ES5 or ES3 or whatever you want. So here I'm going to say ES5, and then I will generate a source map as well, with yeah, sure. Yeah, sure. Sure.
If you got some example,
Yeah, yeah, sure.
maybe you just code up the code.
Yeah, sure. Yeah, so yeah, sure. Yeah, sure. Yeah. So here I wrote a bunch of commands which are nothing but the same as that of what I wrote over there. So additionally, I'm writing a $-, watch command, which is nothing but you don't need to each time run each time compile a file which you have specified. So over here, saying that please compile app.ts. So now I go to close a terminal, and this is the way by which you can run your task, and that's it. Like when you run a C# code, you just do a control bit, and thereafter you press a F5 to run your application. So in this way you can do it. Like I need to run a task, so I press a Control Shift P, and in that I will say this thing. So as soon as I I did a command B for running a build task, so it will every time I change anything inside my file, it will looking for that, and I don't need to compile it again and again. So see if I say something else, send a file, and if I check JS file once again, as soon as I save it. As soon as I save it, it will see here in a console you can see as soon as I save the file, it says that file changes has been detected, and compiler started compiling that specified file and transpile it to a JS file. So as soon as I save it, you can see that there it has something else console got there, and there is one more line at the end of the file which is nothing but it helps to it creates it helps to when it comes to a debugging, as you wrote your code in a TS file, you should also debugging a TS file only. So the map file is what it helps while debugging. So we can take a look at that as well. And see. So let's move on to a debugging phase. So here you can debug your whatever JavaScript file is there. So same way you can debug a Node.js files as well in VS Code. So but now we are going to debug a app.ts. So if you look at this left hand side window, you can see a variable watch, call stack, and breakpoints are appearing over there. So as soon as I add a breakpoint, you can see there is a breakpoint tab. Breakpoint section is filling up. So it is the same as that of Chrome tool. So when I try to debug anything, it will says it ran this thing. So well, so I need to first create a launch.json, which will help us to create our application to be launched, and we can debug it so that we can hit the breakpoint and all. So as soon as I clicked on the launch button, it opens a launch.json, and if you go back to our main directory, you can see that launch.json gets added inside a VS Code. So this VS Code is nothing but a private folder which has been that has been watched by our task manager or the debugging for a debugging purpose. So that level configuration have been placed over here. So if you this is a pre-populated thing. And now, so here I mention what kind of configuration you are using for debugging purpose. So I said node, and then this name can be whatever. If you change it, it will appear over here in debugging console. You can see. So there is two kind of options are there. So one is launch and the attach to process. So attach to process is if anything is running on a server on any port, we can attach to that port using attach to process method. So it is the same as that of these two options are appearing over there with name, attach to process, and launch. So over here what I'm going to do is I'm going to debug this file app.js. So what I'm saying is in program option you have to provide your program path. So that could be your program name which you wanted to debug, and then over here this is the current workspace directory which is the root of my application. So over here, see, I'm going to provide an app.ts. So yes.
So
Yes, sir. So this way I can debug it. You
switch it on.
This way I can debug it, and you can look into all the variables. As saying that what you do in a console of Chrome, and then there are these features are nothing but added by TypeScript, which is nothing but classes, functions, interfaces, module and namespaces, generics and enums. This all the things are available on servers, backend applications like backend languages like C# and Java, Ruby and Rails and PHP. So I will go over all of these in hurry, but because we are lack of time. So these are the basic types which have been provided by TypeScript. So these are Boolean, string, array. Array is nothing but it can be array of particular entity. Entity can be a class as well or as in interface as well. So there is a enum, tuple, which are the server side concept, and any can be by default any variable which is declared that can be considered as a any, and the void is nothing but if you have any method that isn't returning anything, so that can be considered as a void. So classes, so so in classes, you can implement a prototyper inheritance inside the JavaScript using a function by attaching the function dot prototype property would be a particular function. So over here you can use the same server side concepts to extend your classes and make a inheritance possible like this. Suppose animal is a top level class, and if you wanted to classify as snake and horse, so that can be when I'm going to mention a snake, so I can take a property of an animal which are nothing but a name of an animal and all. So in that case you can see each child is nothing, it's calling a super method, so that the parent extended constructor will get called, and those property will be available inside a snake object whenever I declare it. So the other one is function. So what is the difference between the normal JavaScript function and a TypeScript function? You can have a type specified what it should return. Like if you can see here, add method is expecting two parameters, which is of the first is x, the second one is y, which is of type number, and the next semicolon colon number part is nothing but what type it is going to be returned. So if method is returning something else from that, so it will TypeScript will not be able to compile that file. There is other thing called as interface. Interface is nothing but one of the great type checking part of TypeScript. So here I declared one variable called as new square, and I have said that it is of type square config. So square config, if you look into the property of it has two property called as color, which is a type of string, and called the second one is area, which is a type of number. Suppose if I change this 100 to something else, like if I change area to single quote 100, so it will throw an error, like it will say that it is not satisfying the current interface of square config. And then the major problem with the JavaScript was the code naming, the function name collisions, and function name and function name collisions, when it becomes to big enterprise application. So in that case, what TypeScript did is they introduce a concept called as module and namespace. So what is module? Any function or any variable or any constant can be act as a module. You are going to explicitly export it. Export in the sense what? When one TS file can have a multiple exports. Suppose this file is named as m.ts. So this can have multiple export, and that can be have see, suppose the first export is nothing but an interface. The second one is const, and third one is class. So when I so these three are nothing but these three can be considered as a module as well. So when I am going to import this file, I can say that I just wanted to take a string validator. So what I can say import string validator from my this app.ts path. And the namespace is nothing but one more top level what I can say hierarchy, or in C# and Java as well we have a namespaces. So that is nothing but what they did is, because of namespaces we can have a same name classes in a different namespaces. So that what you can say, in my application A I have a class called as A, in my application B I have a class called as A. And how they we address them, I can say add method, and over here it will be a b.add method. So over here you can see that namespace is a construct of all the modules it can gather. Okay. Generics is nothing but one more type which is nothing but what the log identity method doing is, it is expecting any kind of object, and that's why I say T means generic. I mean generic. This is again a C, server side language concept where you can say that type can be anything. I can accept any kind of type, and here I'm just logging out the type of T, and if that doesn't have a length method, then I can say that my method is failing, and in that I can throw an error. So over here I did arguments.length. If it is not of it is, if it that method isn't a list or array, that will throw an error saying that length property doesn't exist on that object. This enum concept is again from derived from server side language only. What we did is for a particular variable we defined a different string literals kind of thing. So over here I did a language that is nothing but a Java, C# or a JavaScript, and if I do suppose I wanted to choose one language called Java, so I can do var language is equal to language.java. So when this assignment happened, what it does is when language variable gets created, it gets created with a type called as a language enum. So if I try to assign one different value to it, like a language not a member of card suit, so it will throw an error like saying that error string is not assignable to the type language, because that language variable got created of a type language. So yeah, as I said, if you are good, there is an alternative to TypeScript. Like first thing, what you can do is you can improve your skills in a pure JavaScript. You can learn patterns, and you can you can spend time on that and decide on basis of your project which pattern should I use and all, and you can use that. So by that you can neglect TypeScript. And there are other language which are there like a TypeScript, that is Dart, which is used by Google, and there is one more called as CoffeeScript, but they are not that much famous as that of TypeScript, because like TypeScript provided many more features since then when it was developed, and it maintains by Microsoft as well. So many open source community supports it and contribute to it. That's it.
If we may go further, so quick question, please. All right, thank you very much. Okay, this sums up our talk. Thank you all for coming, and we'll follow up with the lunch of the guys. And also, we'd like to announce that we may, organize a hackathon this month, so you all are invited. We'll show all the dates and video and everything. And also, Ravi, yeah, you want to talk? Yeah, you are to speak something. And I think we don't have much time for lightning notes.
Yeah, hi. So, thanks, Richard. Yeah, I just wanted to. I just wanted to first of all thanks for coming in. And one point I wanted to share from DigitalOcean was that if you're looking to speak at these events, sometimes you have this question about, no, I don't have the content, I don't have the time to present the content, prepare it or material around it. So what they are thinking of is creating something called content packs in various areas. So for example, high availability on DO, how do you do that? So they are suggesting that they could give us presentations in terms of slides or decks, as well as tutorials or materials. So if that idea is attractive, if you feel that if that would probably give you the jump start to even talk at these events, we can let them know about it. So if you're looking to speak but don't have time at times to prep a deck, but you're looking at some guidance material, they're looking at creating various content packs. So we can just touch base on the community group back and see if they would want to help us out on that. Yeah, but apart from that, yeah, thanks to all the speakers. It's been informative, and thanks for joining in.
And yeah, just in case if you'd like to join our team, Girish is the person to talk. Thank you. Thank you all.